Hello everyone, and welcome to lecture 4. Now let me go to lecture 4, and this is going to be on section 2.5 in the textbook, which is on quadratic equations. Quadratic equations. Okay, so first thing, what is a quadratic equation? So basically a quadratic equation has the form ax squared plus bx plus c equals 0. And what makes it quadratic? It's the exponent of a 2 there, right? That's what makes it a quadratic equation. Now, in this section, we want to talk about different ways of solving quadratic equations. So one way of solving quadratic equations, if it's possible, and it's usually the quickest way, is by factoring. So let's talk about that first. Let's review that first. So solving quadratic equations by factoring. Okay, so let's say I have this equation I want to solve. Let's say x squared plus 13x plus 30 is equal to 0. Okay. So one thing I could try is to factor the left-hand side. Now, the nice thing about this is the coefficient of the x squared term is a 1, right? There's a 1 there. So if it does factor, I know that I can write down my parentheses for my two factors. I know that the only way I can get x squared, 1x squared, is x times x, right? Then to figure out whether this factors exactly or not, I have to think of two things when multiplied will give me 30, right, which is the c term here. So two things multiplied will give me 30, and then when added will give me the b term, the positive 13. So can you think of two things that multiplied give me positive 30 and added give me positive 13? Yeah, if we start thinking about, all the factors of 30, like 1 times 30 or 2 times 15, so on, you're going to find that if you do positive 3 times positive 10, if I multiply those, I get positive 30, and if I add them, I get positive 13. So that these must be, and it doesn't matter what order I write these, right? Either say plus 3 and say plus 10. And then, since I have two things multiplied to give me 0, think of this as sort of like, this is like a, right, times b equals 0. So either a is equal to 0 or b is equal to 0, right? They'll both, if a is 0, 0 times b gives me 0, regardless of what b is. And if b is 0, a times 0 gives me 0. So either factor could be equal to 0. So I have to try both of them, right? So I'm going to solve the first one. So a was x plus 3 equals 0. And the second one was x plus 10 is equal to 0. So if I solve the left equation here, I need to subtract 3 from both sides. So one solution is x is equal to negative 3. And then for the right one, I need to subtract 10 from both sides. So that solution would be x is equal to negative 10. Okay, here's another example. Let's say I want to solve m squared minus 4m is equal to 0. I'm going to solve that quadratic equation for m. So the way to think about this is you should always try and factor out whatever is common to both terms first. So if I look on the left-hand side, it looks like an m, right, is common to both terms. So I can factor that out front, and I'm left with what? Well, to get m squared, I need m times m. And then to get negative 4m, I need a negative 4, right? Because if I were to distribute this m back in, I'd get what I started with, right? M squared minus 4m. So that must be the factorization. And then again, I can argue that one possibility is that m is equal to 0, and the other possibility is m minus 4 is equal to 0. Well, this is all done, right? So one solution is m is 0, right? That will make the entire thing 0. The other possibility is if I add 4 to both sides, I can solve this one, and I'm going to get m is equal to positive 4. So I have two solutions. And by the way, you can always check these, right? You can take these solutions and then plug them back in where you have m in the original equation, and you'll see that you're going to get 0 for both 0 and 4 when m is 0 and m equals 4. Okay. What if we have something a little more complicated? So let's look at this. Let's say I want to solve (7x squared plus 25x minus 12 equals 0. So here I can't easily factor this, although you could use guess and check. Let me show you another way. And the other way is going to be by something called grouping. So say by grouping. And hopefully this will be possible, because it's always quick to factor if it's possible to factor at all. So what you do is you multiply the a term times the c term. Okay? So I'll do it on the side over here. So I have positive 7 times negative 12. And that's going to give me negative 84. Right, so I multiply those together. Then I want to think of two things when multiplied give me the negative 84, but then when added give me the b term here, which is the positive 25. So think of all the things, all the factors of 84 again. Like, you know, you could do, say, negative 84 and positive 1. If I multiply those, I get negative 84. But if I add them, I get negative 83. So that doesn't work. Remember, the goal is to add them to get positive 25 in this case. So then you try something else, maybe 84 and negative 1. No, that won't work, right? If I add them, I get 83. You could do like 42 and let's say negative 2. But if I add them, I get 40. That doesn't work. I could do it the other way, negative 42, positive 2. If I add them, I get negative 40. That doesn't work. And eventually, if you start thinking about this, you're going to end up with negative 3, positive 28. If I multiply those two together, I get negative 84. And if I add them together, I'm going to get a positive 25. Okay? So what you do now is you rewrite that middle term in terms of these two factors here that you found. So I rewrite the positive 25x in terms of those two factors. So this would now be 7x squared. It doesn't matter what order I write these in, by the way. I'll do it this way, just to plus 28x minus 3x, right? So 20x minus 3x is 25x. I'm just rewriting it in a different way. Minus 12 equals 0. Now here's where we factor by grouping. So I would group the first two terms. You can think of this as plus a minus 3x, right? And I'm going to group the last two terms. And then what you do is you factor the greatest thing that you can, like the most that we can from that first grouping. Well, what's common to 7x squared and 28x? It looks like 7x, right? So I can factor out a 7x, and I'm left with x plus 4. And then ideally, I like to factor something out of the second group so that I'm left with x plus 4. And actually, in this case, if I factor out a negative 3, then I'm left with x, because negative 3 times x gives me negative 3x, and then plus 4, because negative 3 times 4 gives me my negative 12. That's great. The whole goal is to try and get these to match, right? To get the same thing. Why? Because now they're common to both terms, so you can factor the entire x plus 4 out front. I can bring it out front, and now I'm left with 7x, right? Because x plus 4 times 7x will give me that first term, and then minus 3, because x plus 4 times minus 3 gives me that second term, equals 0. Okay, so this is factoring by grouping. So now we have to do a little bit more work to complete this. So remember, now the argument would be that the first expression, first factor, could equal 0, or the second factor could equal 0. So then I solve the first one. That's easy enough. That's just going to give me x is equal to negative 4. And solving the second one, so this is 3. So I have 7x is equal to 3. Now to get x, I need to divide by positive 7. So it looks like x is equal to 3/7. So those are my two solutions. X is equal to negative 4, and x is equal to 3/7. Okay, here's another example. Let's say I have 3m cubed minus 36m squared plus 96m equals 0. Now this looks like a cubic equation, right? It doesn't even look like a quadratic equation. But remember, when we're solving this, we always want to see if there's something common, right, the greatest common factor that we can take out of every term. So is there something common to 3m cubed, negative 36m squared, and 96m? Yeah, 3m, right? So 3m is common, so I can pull it out front. And I'm left with what? I'm left with m squared, because 3m times m squared gives me 3m cubed. I'm left with negative 12m. And then 3m times what gives me 96m? I guess it's plus 32. And that's going to equal 0. Okay, so we did have a cubic equation to start with, but now we sort of reduced it into 3m times just a quadratic expression. And we should be able to factor that. So let's see if we can factor that quadratic. So I still have the 3m. I'll leave that out here. Now I can just draw my parentheses because I have a 1m squared. So I know the only way I can get m squared is m times m. And then I want to think of two things when multiplied will give me 32 and added will give me negative 12. Two things when multiplied will give me 32 and added will give me negative 12. Well, again, if you think about this a little bit, it looks like negative 8 times negative 4, right? That'll be positive 32. If I add them, I get negative 12. So this is going to be negative 8 and negative 4. So now, for the solutions, there's three possibilities. I have 3m, that could equal 0. M minus 8 could equal 0. Or m minus 4 could equal 0. Well, this one just says m is 0. In fact, if you want, you can divide by 3. You can formally divide. And of course, 0 divided by 3 is 0. So that's one solution. M is equal to 0. And the next one I have m minus 8. So if I add 8 to both sides, I'm going to get m is equal to 8. And then finally, m minus 4 equals 0. So if I add 4, I get m is equal to positive 4. Okay, here is, let me do one more with factoring. I'll do some more in class as well, but for the video lecture, I'll just do one more. So I have x squared minus 25 equals 0. So this is something you guys should recognize. It's called a difference of squares, because this will come up a lot. Difference of squares. And what it says is if you have a squared minus b squared, this factors into a plus b times a minus b. Okay, so really on the left-hand side here, you can think of this, right, as x squared minus 5 squared. So this factors, left-hand side factors into x plus 5 times x minus 5. So now if I set each of those factors equal to 0, I can solve this, right? One solution is going to be x is negative 5. And then the other solution will be x is equal to positive 5. Okay, great. Another way we can solve quadratic equations is using what's called the square root property. So I'll say using the square root. Property. What this says is if you have an equation that says x squared is equal to k, then the solution, if you solve that for x, it's going to be equal to, you got to be careful here, plus or minus the square root of k, right? Both of those are solution, because if we plug that back in, if we plug in positive square root of k and we square it, we're going to get k. If we plug in negative square root of k and we square it, we're still going to get positive k, right? So there's two possibilities, two solutions there. Okay, so for example, let's say I want to solve 5v squared minus 160 equals 0. And I'll use this square root property. So in order to do this, I need to isolate the variable, which is the v in this case, the v squared. So what I would do, let me just write it one more time. I will bring the 160 to the other side, so I'll add 160 to both sides. So I have 5v squared is equal to 160. And then I'm going to divide both sides by 5. So divide by 5. And that's going to give me v squared is equal to 32. Now I'm going to use the square root property, right? So basically, I'm going to take the square root of both sides. But I have to remember the answer could be positive or negative. So square root of v squared gives me just v. And then I have plus or minus the square root of 32. And then I can simplify that, right? If you do the prime factorization of 32, so if you do the tree here, 2 goes into 32 16 times, right? And then 2 goes into 16 8 times, 2 goes into 8 4 times, and then 2 goes into 4 2 times. So another way of writing 32 is it's equal to 2 times 2 times 2 times 2 times 2, right? 2 to the 5th. I have 5 2's there. So if you want, you can think of it like this. I have v equals plus or minus, and I have really 5 2's here. But a pair of 2's can come out as a single, right? It's like saying the square root of 4 is 2, so that comes out as a 2, and this one will also come out as a 2. So this is going to be plus or minus 2 times 2, and left inside I just have 1, 2. So my final answer would be v equals plus or minus 4 times the square root of 2. And you should always simplify it. Instead of leaving it as square root of 32, simplify it to 4 times square root of 2. Okay. What if I have this? If I want to solve b minus 9 squared is equal to 2. Okay, so actually I kind of have the squared term isolated. So I can use the square root property, right? Immediately I can take the square root of both sides. But remember, this is plus or minus. Well, the square root of b minus 9 squared is simply b minus 9. And the right-hand side, I just have to leave as plus or minus the square root of 2. And then finally, I can add 9 to both sides, right, to get the b. So then b is equal to, I could write this as 9 plus or minus the square root of 2. So really, this is saying there's two solutions, right? One solution is b is equal to 9 plus the square root of 2, or b is equal to 9 minus the square root of 2. Okay, another technique that we can use to solve quadratic equations is something called completing the square. So completing the square. And the goal is to rewrite the equation to get a perfect square trinomial on one side of the equation. So to get a perfect, it's called a perfect square trinomial on one side of the equation. And then once we have that, we can use the square root property to solve. So I'll say, then use the square root property to solve the equation. Okay, so how does this work? Well, it'll be easiest to explain by example. So let's say I have this equation I want to solve. So I want to solve x squared plus 20x plus 96 is equal to 0. And I want to solve it by completing the square. Okay, I'll say by completing the square. Okay, so the way that we do this is so first of all, notice that in this case, right, I'll write this one more time. See how I have a 1 is my coefficient of the x squared term, 20 is the coefficient of the x term, and my constant is 96, right, positive 96. So what this is saying is like a equals 1, b equals 20, and c equals 96. Right, remember, it's ax squared plus bx plus c equals 0. That's the definition of a quadratic equation. So what we do is we bring the c term to the other side. Okay, so to do that, I need to subtract it. right? So it's going to be negative 96. And so I'm just bringing the c term to the other side. So I need to subtract it from both sides. Okay, so now the question is, what do? We want to add something in this location. We want to add something here so that this left-hand side becomes a perfect square. They call it a perfect square trinomial, right? Because it'll have three terms. But whatever we do to one side, we have to do the other side. So whatever I add there, I have to add the same thing here on the right-hand side, right? Because I can't just do something to one side of the equation. I have to do it to both sides of the equation. So what do I add? Well, what you add is a half of b squared. So I'll write that over here. So we want to add a half of b squared to both sides. Remember, b is 20 in this case, right? So I want to add a half of 20, which is 10 squared. So this is 10 squared, which is 100 to both sides. Okay, so left-hand side, I have x squared plus 20x plus 100 is equal to negative 96 plus 100. Now, it turns out by doing that, by adding a half of b squared, it makes this left-hand side into a perfect square trinomial. In fact, the left-hand side ends up being x plus half of b, this is 10, squared. So we added half of b squared, but this term right here is just half of b. This is just b divided by 2, right? Half of b. And that's got to equal, well, what's negative 96 plus 100? The right-hand side is just 4, right? So it really simplifies the whole thing. So now I just have x plus 10 squared is equal to 4. And that I know how to solve. I can use the square root property, right, to solve that. So if I take the square root of both sides, remember this is plus or minus. Well, left-hand side is just going to give me x plus 10. Right? Think of it as it undoes the square. So x plus 10 square. When I take the square root of the whole thing, I just get x plus 10. And right-hand side, I'm going to get plus or minus. And in square root of 4, 4 is also a perfect square, so this is just 2. Now I can bring the 10 over, so subtract 10. So one solution is x is equal to negative 10 plus 2, which is equal to negative 8. And then the other possibility is x is equal to negative 10 minus 2. So that solution would be x equals negative 12. So those are my two answers. So negative 8 and negative 12. Okay, and again, I'll do more problems like this in lecture. Actually, let me do one more where the coefficient is not a 1, okay? And show you how to handle that. So let's say I want to solve this. Say I have negative 5x squared plus 70x minus 200 is equal to 0. And I want to solve it by completing the square. So in order to complete the square, the coefficient of the x squared term has to be a 1. And right now it's negative 5. But what we can do is we can divide everything by negative 5 first, right? We can get rid of that negative 5 there. So I'm going to say we want 1x squared, right? So we're going to divide both sides by negative 5 first. Okay, and we'll see how that works, right? So I have negative 5x squared plus 70x minus 200 is equal to 0. So if I divide this by negative 5 and divide this by negative 5, remember left-hand side, really this means this, right? Negative 5x squared over negative 5 plus 70x over negative 5 plus negative 200 over negative 5. And then right-hand side is 0 divided by negative 5. Well, what's negative 5x squared divided by negative 5? That gives me what I wanted was the 1x squared. Then what's 70 divided by negative 5? It turns out it's negative 14, right, x. And then negative 200 over negative 5 is 40, positive 40. And then 0 divided by negative 5 is just 0, right? 0 divided by anything is 0, as long as the denominator is not 0 itself. That's 0. Okay, so now I want to continue solving this by completing the square. So I need to get the 40 on the other side, right, the c term, so I just subtract 40. So I have x squared minus 14x, I'll leave a little space there, equals negative 40. Now I want to add half of b squared. Well, b is negative 14, right? So half of negative 14 is going to be negative 7. This is negative 7, and I want that squared. But that's a positive 49. Right, so I'm going to add a positive 49 to both sides. Okay, so it turns out the left-hand side is now a perfect squared trinomial. And what is it? Remember, it's going to be x plus half of b. But half of b was negative 7, so this is negative 7 squared. You can check it. You can FOIL this back out, right? Multiply x minus 7 times x minus 7, and you better get back that original trinomial above. And that's got to equal, well, negative 40 plus 49 is positive 9. So now to solve this, I'm going to take the square root of both sides. Remember, it's plus or minus. So that gives me x minus 7 is equal to plus or minus. Well, square root of 9, that's easy, that's 3. And then finally, I can add 7. So one possibility is x is equal to 7 plus 3. So that gives me x is equal to 10. That's one solution. And the other possibility is x is equal to 7 minus 3. So that gives me x is equal to 4. Okay. Okay, now there's one other way. Let's say that, well, completing the square will always work, but sometimes there's a little bit of work to figure it out. Factoring may not always work, right? It might not be easy to factor the quadratic expression. So another way of solving quadratic equations is using what's called the quadratic formula. So using the quadratic formula. And for now, I'm just going to give you what the quadratic formula is. And in lecture, right, when we come in the 1 day per week, whether you're group A or group B, I will derive it. And I'll derive it by actually using completing the square. You can derive it by completing the square. Okay? So if I want to solve this quadratic equation, ax squared plus bx plus c is equal to 0, using the quadratic formula, it turns out that the answer is going to be that x is equal to, and you probably have heard of this before, negative b plus or minus the square root of b squared minus 4ac, right? All that is underneath the radical, all divided by 2a. And again, I will derive it in class using completing the square, but for now I'm just going to give it to you. So let's do let's do a couple of examples using this quadratic formula, and that'll be it for this lecture. Let's say I want to solve this quadratic equation. 4p squared minus 3p minus 6 is equal to 0. Okay. So first thing you should do is you should figure out what a, b, and c are, right? So in this case, a is the coefficient of the square term, so that's the 4, right? Our variable happens to be p in this case. B is the coefficient of the linear term, so in this case it's the coefficient of the p term, which is negative 3, and then c is the constant, which is negative 6. So now I'm going to plug in. So I have, instead of x, I have p, right? So p is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, then we have to work this out, right? So, well, a negative 3 is positive 3, so this is 3. Plus or minus, I'll do this in a couple of steps. Negative 3 squared. You got to be careful, right? The 2 here is acting on the entire negative 3, so it's negative 3 times negative 3, which is positive 9. Then I have a negative 4 times positive 4 times negative 6, that's a positive 96 over 8. Okay, and then finally, I can say p is equal to 3 plus or minus. This is the square root of 105, and that's all divided by 8. So that would be the answer. So, and actually, if you want to split this up, you could say one answer is that p is equal to 3 plus the square root of 105 all over 8, or p is equal to 3 minus the square root of 105 all over 8. And we can't really simplify it much more than that. Okay, let me do one more example. So for this last example, let's say I want to solve 9x squared plus 18x equals negative 11. Okay. So first thing, bring the negative 11 to the left-hand side. Write it in that standard form where I have ax squared plus bx plus c equals 0. So I need to add 11 to bring it over here. So it'll be 9x squared plus 18x plus 11 equals 0. Okay, and now I can see that a is going to be 9, b is going to be 18, and c is going to be 11. Okay, so I'll plug into my quadratic formula. I have x is equal to minus b plus or minus the square root of b squared, so 18 squared, minus 4ac all over 2a. Okay, so now, again, I have a little bit of work to do here, right? So inside the radical, or underneath the square root, well, 18 squared, you can just do this on a calculator, is going to be 324. And then I have minus 4 times 9 times 11, which is 396. All over 18. But 324 minus 396 is negative 72. Okay, and it looks like we can simplify that further, right? So negative 72, first of all, let's factor 72. Okay, so if I factor 72, it's going to be 2 times 36, 2 times 18, 2 times 9, and then 3 times 3, right? So it'll be 2 times 2 times 2 times 3 times 3. So you can think of the square root of 72 as being the square root of 2 times 2 times 2 times 3 times 3. And a pair of these factors will come out as a single factor, right? So the 2 comes out and a 3 comes out. And I left inside with just a 2. So this is really 6 times radical 2. The other way you could have gotten this, if you recognize that 72 is 36 times 2, and 36 is a perfect square, right? So it comes out as a positive 6. It's a quicker way. But this will always work if you go all the way down to prime numbers, if you do prime factorization. But we don't have square root of 72. We have the square root of negative 72. But that's close, right? Because remember, the square root of negative 72 is equal to the square root of 72 times the square root of negative 1. But what's the square root of negative 1? That's I. So this is really going to be 6 radical 2 I. Okay, so if I go back here, minus 18 plus or minus 6 radical 2 I all over 18. And then I can simplify a little bit further because it looks like a 6 is common to both terms in the numerator. So I could pull out a 6, and I'm left with, well, 6 times what will give me negative 18? I need a negative 3. And then 6 times what will give me 6 radical 2i? Well, just a radical 2i, right? If you were to distribute this back, you'd get where we started. Why is that helpful? Why do I need to do that? Because look what happens now. I can simplify 6 over 18, right? So I can I'll write it one more time. Six goes into 6 once, 6 goes into 18 3 times, right? 6/18 is the same as 1/3. So that means my final result is going to be x is equal to negative 3 plus or minus the square root of 2i all over 3. So that means one possibility, right, is that x is equal to negative 3 plus radical 2i over 3, or x is equal to negative 3 minus radical 2i over 3. If you want, you could even write them as in complex number form, like a plus bi, if I put everything over 3, right? So I could write this as x equals, well, negative 3 over 3 is negative 1 plus radical 2 over 3i, and this one is negative 1 minus radical 2 over 3i. So those are my two solutions. And really all these forms are correct here. It just depends on how you want to write it. Okay, great. So that's it for section 2.5. And again, we'll do more examples in lecture, and I also will derive the quadratic formula. Great, thanks.